presentation titled bSDD and IDS for Fire Safety with Prescriptive Method and Residential Project, Fire Safety Engineering and Fire Risk Assessment, now developing new openBIM workflow, and IoT Interoperability Project Whitepaper findings. The speakers for this session are shown on the screen. This session is scheduled to last 90 minutes, including time for question at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. I would like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and standards that developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. Now I would like to hand over to Manuel.
Thank you for the introduction. I will present about fire safety requirements, and we will show how we developed for the use case of the regulatory permit and IDS, and I will introduce that from the fire safety perspective, and afterwards Mirbek will show the technical use. I describe this as my travel to BIM because today I'm at the Technical University in Munich. I'm a researcher there at the Professorship for Fire Science and Engineering. I'm convener of the DIN Standard Committee for Fire Safety Engineering and a speaker of the Fire Safety Group at buildingSMART Germany. But where do I come to there? We skip that and keep this for the evening. I experienced 14 years as a fire safety engineer until mid of this year at Hafkanenkirchner, doing fire and evacuation simulation and working on the first projects with BIM. Besides, we are connected in an association named VEB, and we work there together with other companies doing the same on fire safety engineering, and we developed a little bit BIM standard and brought it here to buildingSMART. Where did my travel begin? As I said, I was fire safety engineer in a company, and I didn't know about BIM, but we get in contact with the first project with BIM, and we tried to develop working with a model. And in the first project, we take a 3D modeling tool and tried how we could model the information that we usually have in the planning process. This looked like this. And the project went on, and we couldn't follow the process at that time. But when the building permit was there, we were that wide that we could deliver drawings, which we derived from the model. Later on, we developed that, and when the building was finished, we were able to bring additional parts into that model. But actually, we didn't anticipate at that time that there is a really necessary thing to BIM, that is information exchange. So this was a dead end. We had a model, it worked, but without exchange. So exchange information. We asked the question which, and I told you about the association. We sat together in this association and thought about which information do we deliver into the planning process. And we analyzed this from fire protection plans and specified the information we usually delivered in plans. And we did a list. You see here the start of the list in German language. It's not structured, as you know, this for parameter sets or something like that, but it was structured referring to building or building story, room or cluster of rooms, or building components. And we structured in two phases. Said we have some detailed, some design phase in the first decisions, and drawings in the approval phase. Second thing was, how do we deliver those information? We slightly structured it, and we thought of ways how are we delivering that. See, there's this thinking of a model, and everyone is collaborating on that model, and here's a fire safety engineer. And the first steps to exchange information was that architects took the information out of our drawings into their models. And we offered to take the models and look on the models and prove, okay, the information is the same as in our drawings. This is not a good process, you think? I think too, because the logical step is that we get an architectural model annotated with our information and give it back. So this is what I used to do in the last years with pilot projects, but actually there could be another thing. We could have an expert model that is taking part in that process. Now, which should we take there? This is a good question, and therefore I have to look on how we are doing our work, how are we planning fire protection measures. And there are different methods that we are using. The easiest method is we follow prescriptive codes. Yeah? The measures are told in regulatory rules, and we're just following them. Often architects do that for simple buildings, so a fire safety engineer is never asked. Then we have a performance-based way. We simulate and approve objectives and criteria. And then there's another way that is like a tailored safety design when we take the risk into account. And actually, if I'm on that easiest step, there is a question, do I need an expert model for that? So these were the questions that we were following and that we were talking. And at the same time, we made a list on what are the use cases. And you see what we are doing is like fire simulation, occupant movement analysis, and this will be presented in the next presentation. There are some others, but they all are interactive with the information needed from the general safety designer and deliver information to this general strategy. And in every case, we usually deliver information to the authorities for the main regulatory process. So we focused on that. And in the process, we see this is a waterfall. We go in the pre-design, have the fundamental decisions that are requirements for the next steps. And finally, at the approval process, we will have the requirements for fire safety that will be fulfilled from other planners that then afterwards plan for the construction. With the experience of the first projects, we developed a structured list of parameters that nearly completely is able to transport information for the approval process. You can find that list at the side of the VIB, and it's in German language. It's structured also in the two phases. It delivered parameters with names, annotated classes, and value types in the IFC. And as we are an association in the DACH room, also in Germany, Austria, and Switzerland, we had some attribute values proposal for these three countries. We delivered that to the fire safety group of buildingSMART Germany, and together with the technical knowledge from buildingSMART, we did that as a first draft for bSDD. We developed this first proposal from our association in that kind that we did 5 parameter sets that structure the information a little bit better, not broken down to every IFC class, but to a cluster of classes that makes sense for fire safety engineers. And we analyzed the information that is there and identified some possible collisions with existing parameters that we will have to look upon. And You will find this in the bSDD. We delivered that there together with my colleague Mirbek, and he will present you now, and I hand over to you how this works with the technical process.
Thank you, Manuel. I will skip that part in one. Okay, maybe back. I'm volunteer firefighter. That's only connection, maybe as a building physicist, a little bit connection to fire safety. That's all. Okay, we worked on dictionary. So as you can see, the dictionary is there. You can just follow the bSDD site and write down fire safety, and you will find directly this dictionary. As Manuel already mentioned, we have classes. So we thought before we'll start with any classification, we need to know which objects we're covering. That will be building components. So it will be building itself. So we need to know if we can cover that with IFC. Luckily we can, and we could, and we did it. So we have a classification in that case. So we have buildings. Buildings are mapped with IFC building in that classical way. So we have the list of classes that you can see in that 23 one, and we have 33 properties that we captured in that table from VOB, and 5 group of properties. So this time we didn't cover anything like geometry or material. Maybe in the future there will be some considerations, but we currently trying to use a bSDD as a single source of truth. That's a really interesting fact, because everyone says, yeah, IFC would be in that case. If you use bSDD as a single source of truth, you can use bSDD content to create IFC by using APIs and applying them to objects, or you can same way create requirements, because within bSDD you have dictionaries, including IFC dictionary. So you don't have to reinvent the wheel. You check what you have there and what is missing, and that's what we brought now, missing part into bSDD, those fire safety requirements, and the idea. The possible way to harmonize values, possible predefined values from properties, regionalize or put regional content, like let's say German, Austrian, and Swiss content. Not only that, the bSDD is, so you're able to do international content as well. And first we focused on ISO content, so you can now add additional properties, additional predefined types, additional enums, p-enums. So you have a chance to do that, and plus additional translations. That's what bSDD allows you to do. And at the end, we thought, okay, we use bSDD as a content for creation ideas. We spent no time to create these ideas. It was exactly mapped directly from bSDD. What it brings me, the single source of truth, content is there. I don't have to copy paste anything, minimize my error. So you can simply scan this QR code as just example, or later on get it through platform. You can try that as well. There is machine readable upon request. This is human readable of ideas. There are you can 2 ways of representing. If you are quite not familiar or like quite new to the ideas, you will open XML schema like, oh. So you have to provide ideas also in human readable way, at least at the beginning, saying you have a model as a building. Building should have a property, let's say fire safety class, classical way. So that will be able to read it after all. So that's how it looks like, by the way. That's human readable side. So you have here BIM, the BIM. I want to do BIM, then you have to have IFC class for that, IFC BIM with probably predefined types. You have now classification, as you can see, you can point it, I don't know. So you have a classification, it's a fire safety requirements at our dictionary, it says BIM, so it should be classified as BIM. And you have to deliver those attributes, and you have to deliver, in that case, you can change it as a template that we provide. According to your project needs, you can change them to be made or to other options, so you don't have to deliver everything. But in most of the cases, we provide those properties so that people, experts outside of the world, I mean, buildingSMART world, using this, they don't have to think of creating additional properties that actually IFC supports or that already delivers, or we, in that case, dictionary. So you can find it and use it. Please use it, that parameter properties instead of inventing your own. And as you can see, you can track the basis like UEIs will track to bSDD. That's an interesting part of connecting as a single source truth bSDD with IDS. That's how it looked like in machine readable way. It's boring in that case if you're more in engineering. Let's say there are two ways of creation IDS, implementing IDS. You can use some authoring tools that import IDS. Other tools are able to, in this case, it's Archicad. They have IDS importer, Vectorworks, I guess, also have IDS importer. So you can simply use this template to fulfill your requirements. So simply use a template and let's say go through the and just assign that property sets to your object building components, and you can simply export them as well. Second way, you can of course validate them. As you can see as an export, we have BSD set space, fire space, so we have those requirements captured now. We can prove that we can deliver that with this method. Second method, we can of course use other plugins. There are like bSDD plugins that also integrate IDS import, or you can simply take IDS as human readable. See, you need simply a BIM or whatever, and it says it has to have a fire safety from my IFC schema. It has to have property sets from fire safety requirements dictionary, and I need some specific values. I simply go to bSDD. Since it's single source of truth, I use the same content back. So it means I can simply assign to specific parameter, let's say that you choose a wall, and as you can see, I can connect directly through API into my bSDD dictionary. Let's say building material class as a fire safety class as A1, fire resistance F90 or E90, that European level, on the legal building element type. So just left it as it is. So I can assign that with one click. It means I have now all that properties, all that class assigned to my model the same way through bSDD. I export that back as IFC. I can validate, since I have the same ideas that I wanted to have, I can send back to the client. Client will, or in that case, like the fire safety engineer can also check the same way if architect fulfilled his or her job did job properly, and they can check, oh, okay, we have some problems here. We had some wrong values. Actually had to be like fire safety, let's say F120 instead of F90. So you can track values as well. So we can send back a message that you have actually issues in that class. You can send and generate BCF. You can, of course, also go deeper and generate some specific topics. Yeah, BCF is actually for that. And you can connect BCF and send back your idea, your requirements back and communicate. Usual concept, assumption that BCF is mainly for design. Actually, in our previous session, we proved that BCF is actually greatly applicable to operation and for renovation phase. You can document every kind of problems, issues on the building envelope or whatever, put your building component as a tag, attach that certificate, photo, screenshot, whatever, and send back to appropriate party so that they can do something as an information, as a task, or as a whatever, for information purposes or documentation for archiving. Later, 10 years later, let's say we renovated window today. So we had the chance maybe 10 years later to renovate gaskets and maybe exchange glass one more time, whatever. So with that, I'm at the last slide. And we are quite on time. And we are open now for next presentation, and we said we will collect all questions, or shall we do questions directly? Oh, we have 8 minutes, so we can have questions.
Questions? All right. We can do questions. Anybody have any questions? Mark? Okay.
Thank you. So what is the find out of your research for the last years? Do you have a way how architects and fire specialists should work together? Will you have a model in future times that we can clash together, or what's the future in your point of view?
Actually, it depends on how deep the delivery of a fire safety engineer for the project is. If we are on the descriptive way that we are just following rules and we have a small building, I don't see a necessary to have a big expert building. On the other hand, when we use these sophisticated methods like fire simulation, occupant movement analysis, or fire risk analysis, I think there will be in future the possibility of an expert model, however it will look, because I'm not so sure what should be included there. But there had been projects in buildingSMART International going, and I think from that we will learn how a fire safety expert model will look in future. And for the processes we learned from the pilot projects that we had in our company, it turned out that attributing the architecture model is a relatively easy way to have a first openBIM transfer of information between fire safety engineers and architects.
Did you were presenting the kind of properties and kind of alphanumerical information, but how about, did you also study how to model the fire safety zones or fire like escape routes? Because that's kind of the fire regulation, or the regulation which kind of controls that what parts of the wall should be EI 60 or EI 30 or something. They are not following the objects, the entities. They are the zones are typically due to there's between two rooms or two different types of spaces, but sometimes it's more. It's not even following the geometry of the spaces. So did you study the geometrical properties as well?
Yeah, I identified the problems that that the IFC space that comes from the architect is not the same that we would use for fire safety considerations. Actually, we didn't address this with that parameter set, but we see the problem, and we have first tests on looking on other data structures to cover this problem, but this is not the focus now of this thing here. Yeah.
Okay, any other questions? All right, we can move on to the next.
We had also a question regarding zoning, and there is a specific IFC entity or class, and there was a technical report in the past, in building domain, by the way, IFC spatial zone. You remember the technical report, and IFC spatial zone, it has specific predefined type, and difference, or let's say side effect of IFC spatial zone, it's independent from a structure like IFC space, right? You have different way of creating it, but the problem that it doesn't show you the boundaries, right? If you use IFC space, that was a finding we in the past was fire safety engineering project, and who will be reporting now. We had analysis between 3 ways of creating elevator shaft or elevator representing. The first case was to use IFC spatial zone, like we thought, IFC spatial zone, predefined type, transportation, or whatever we had. And it didn't work well. Second was IFC build system, I guess, or building system now it's called. It was a change so far. That was also tricky. And we made a conclusion that the best way was to cover IFC space, as you use IFC space story by story, and connect them as a normal classical way with IFC zone. In that case, IFC zone is a whole zone, is our elevator shaft. So that was a different examples how you can find out how you can use the existing IFC structure to address something. Compatibility, compatibility compartments or fire compartments. There is also possible entity and property for that in IFC. So that's we also guys checked, and we didn't explicitly brought the stuff into bSDD. We skipped that part in IDS, in bSDD, but we covered that in IDS. We brought back missing entities, types, and property size with property from IFC into IDS, but not into bSDD because it's already there. Yeah. Tony, you have a question again?
Another one.
Yeah.
How about then, because we have a requirement, which is kind of the regulation, but then the requirement is typically different than the actual fire rating of the wall. So the fire rating of the wall can be a lot higher. It's typically, if you have a concrete wall, it's typically 180 minutes. Whereas the regulation could be just 60 minutes.
So it means we have, I guess that's covered by minimum requirement. So it means then actually Manuel should answer that question. The typical way that we refer coming from regulations, and if regulation says for escape routes, the door should be minimum 1 meter wide. It says minimum, right? So you have to put that as a minimum already in your IDS as a minimum, not more, not less. Then you will, if it will be 1 meter or 1 meter or 1.5 meters, it doesn't matter because you are still meeting that requirements. And it will be not in bSDD, but bSDD provides only the property that you can apply, but the value will be captured in IDS. And again, bSDD will be provided for your model creation, and the value you have to either add by yourself, but in most of the cases, door widths will be calculated by itself, so you have to design it properly.
If you,
We have, in Finland, we try to implement both to both pieces of information, because if you look at the whole life cycle of the building. So if you look at the whole life cycle of the building, typically the fire rating requirement is based on the kind of the difference between two spaces. So between two spaces, you need a certain fire rating, let's say 60 minutes. But if the occupancy type of one of these spaces changes, also the fire rating requirement could be higher. And if you look at maybe after 5 years, the building is completed, you change the occupancy type of one of the rooms. And it has an impact that, okay, now the fire rating of the wall needs to be higher than it was originally. Now, if you only know what was the original requirement, but you don't know what is the actual outcome, then what do you do? Then you need to study, or maybe you need to do something for the wall. But if you know that it's actually the wall is already 180, then you don't have to do anything. And that's why we are storing both pieces of information, both the actual fire rating and the requirement. Typically, the requirement is less than the actual. Just an example how we try to also serve the kind of the life cycle of the building.
yeah, but this addresses actually this problem, because we said we need another parameter that is not the fire rating, that is the fire rating requirement. So at the stage when we have the approval, we actually don't know which fire rating the wall will have, because it might be a wall of gypsum board, or it might be a concrete wall. Yeah, I don't know that at the time, but I know it should have at least the RIE 60 at that moment. And the second thing that this is derived from the usage of the according spaces. We address this in another project that we are working on, actually, where we try to derive the requirement out of the neighborhood from spaces. But this is not developed yet to a standard that I would present it here.
Last comment, if it's...
I totally agree that in the building permit stage, you only know the requirement, but we now, because of the new legislation in Finland, we need to provide also the as-built models to the authority, and that's kind of part of the building permit process. The building permit process ends when the building is finished and you deliver the as-built data to the building authority. I know that it's really, it's scary, but okay, but that's how it goes.
Let's keep that discussion at the end. Thank you, Tony. Keep that in mind. There is a great standard called PCF. You can track everything and tell we need to update the model according to new usage of that area. That's, I think, is the best way. Now we have to proceed with the next presentation. We're out of time.
Cool. Thank you, guys. Is it working? Yep. Yeah, it's a bit much now. All right, firstly, thank you for joining us at such a late time after all the brain... Okay, yeah. Yeah, it's been an intense day, and I'm sure it's coming here at such a late part of the day is going to be quite mind-numbing. But I've got that beer garden staring at me as well, which is really starting to tempt me. Okay, so IoT interoperability project. Today we're going to introduce what the project's about and discuss and just present some of our initial white paper findings. So I'm Sam Norledge. I'm the head of smart buildings at LMG. We're a master systems integrator and a systems contractor. So we deliver network systems and also do the systems integration role, where we bring all the live data together and implement IoT infrastructure.
Guten Tag. I'm from bSDD Japan chapter, and I'm also working as a research engineer for smart buildings at Kajima, which is one of front runners for construction industry in Japan. Great to be here, and it's an honor to work together with Sam and with his greatest leadership, and also with whole buildingSMART UK and I team. Thank you. So, hello.
Okay, I just want to start with this quote from the Realcom magazine. So it's initially what started me out on this project and this journey. So it's basically, I'll read it out for you, but interoperability is a major contributor to the difference between a smarter building and a smart building. Now, that's been a real driver for the project because we know that this interoperability issue within the smart building industry has caused us quite a lot of problems in the past, and we want to share that information and standardize it. And this is what the smart building industry needs at the moment. Without this, we will never be able to unlock interoperable buildings and fundamentally smart cities and all the things that come with that. So I'm going to go through this is kind of what we're going to go through today. So it's a project overview, white paper findings, the initial findings, and then Isan is going to cover some of the mapping with the building device naming schema, which you'll go through in a bit, and the openBIM approaches and next steps. So there's clearly two roles we've identified in smart building delivery, which one is fundamentally there's design data and design engineers creating static information. They typically use IFC when they're kind of designing the assets, spaces, zones, systems, and relationships. So that's in the design phase and operations, but right now, and then we come along as master systems integrators and do the same exact thing. We're building zones, building spaces, building relationships. So it's the same role, same challenges, and it's a duplicated effort. So how it really should be done is we work together with the information manager on the project for a building project. This is working side by side with the MSI, the commissioning engineers, and the design engineers. So we bring together the two data sets and actually create something without duplicating effort, without duplicating errors and things. So by using IFC as a single source of truth, we enable this. So we use that static information from the BIM model, from the IFC, and make sure that that's being followed through the design phases. So I'm just going to go through a typical topology of how a smart building is designed specifically in the UK, but I'm seeing it across the globe as well. So down the bottom here, we've got our edge services. So this is your gateway devices that communicate to a central repository. So this will contain things like your access control, BMS systems, lighting systems. This may be communicating BACnet protocol, Modbus, MQTT, LPC. A lot of different protocols are used. So this is why we have a data ingestion layer. So this is more like a lot of terminology is being used and thrown around in the industry, but a lot of people call it like the building operating system or the BOSS or a middleware. Typically, it's a middleware layer that kind of normalizes that data and structures it and creates a time series database off the back of it of all that live data. And then these are connected into your smart platforms, so your fault detection and diagnostics systems, your digital twin systems, maybe even potentially CAFM systems as well, if you want that live data coming into them. So this is typically via API. So you've now normalized that data. You can send it straight up to the cloud via an API or it's an easier method of integration. And I'm going to go, what I discovered is that there's a lot of things IFC could facilitate during all of these phases. So at the bottom, we can use it as a single source of truth for all the device data. So make sure that all of that device data is being modeled, make sure it's coming to us at the right time frames. Then at the middleware layer, we can use it for building relationships, building spaces, zones, building your XYZ coordinates. That's all needed for your the metadata out of your live data system. And then at the top layer, of course, you've got your visualization element. You can store that model in the cloud and have it as part of your visualization layer. So project updates. So project has been running since 2024. Initially, we created the project proposal, had that approved last year. And then now we've been starting to look into the review of the current research. And then we've produced the white paper, and it's under a peer review at the minute as a draft. And then we are establishing mapping principles with a standard naming ontology. So we've picked one naming standard to follow. That's the building device naming schema, which we'll go through in a bit. And then we're producing openBIM data as well. So we're producing the bSDD and additional alongside that, we're doing the IDS as well. So we've produced two documents. One is the white paper itself. So this is more of a discovery of our findings of our research, what the industry is doing, what we've just gone through there, and where we could go with this project. And we're finding from the back end of 2024, there's been a lot of improvements and changes that we've made to the project, and there's loads of avenues we could go, and it's just developing into quite a big exit. So we've also got the guide for the Smart Building Guide for Information Managers. So this is more of how to use that bSDD and how to use that IDS and what you can actually do with it. I'll just skip that. So where we found there is this divide, is we need to bridge these two worlds. So we're finding that on the information management side, we've got IFC, which is a great standard. But then on the smart building side, there's hardly any standards, and it's quite a critical problem with the industry at the minute. But what we found is there's the building device naming standards that can be used just for asset tagging and IDs. And then for the actual device payloads, like the live data, we would use MQTT typically. And that payload generation needs to be via UDMI, the Universal Device Management Interface, which is just a standard way for that payload to be structured. So we can see there's static data being produced, dynamic data being produced, and this is what's feeding our end models, our BOSS, our building operating system. So this is where we're focusing right now and connecting these two worlds. Also, as part of the white paper, we've produced this mapping table. It just details the different ontologies that we've looked at and different schemas we're looking at. So we've gone through things like the brick schema. That's an ontology model. The DBI, which is more like point naming and tagging. The Universal Device Management Interface. And then the BDNS, Project Haystack, and IFC. So where we're using the static data, we export the IFC type object, get those types into the database. Then we can use that as a parent device. So we would typically, you would in the controls industry, you would have parent-child assets of what controls what. With this, we've got the parent device as a typical fan coil unit. This would be served. The data would be gathered from the IFC model and populated into the parent database. And then you've got the child assets, which are any devices that produce a point, so like a backnet point or a Modbus point, or something that gives you data about that object. And then we've got the types of equipment that isn't modeled. So typically in a building, you've got a lot of sensors, a lot of little things that just won't typically be modeled. That can still be an attribute of a parent. So that fan coil unit, for instance, would have an attribute of what temperature sensors and what VAVs or what is being picked up from that child asset. And then when that comes to the dynamic data, we can use it to feed in data to the into the BOSS. So this is MQTT information. So you've got the asset detail. This is your topic. So the topic covers all of the detail about that asset and what it's producing. That, of course, could be fed from that IFC database because that asset data is in that IFC. The telemetry point data. So this is the actual points that are being produced. This can be fed from a different ontology or like the digital building ontology. You can gather it from a lot of different things, but we've still got that link with the IFC. And then you've got your locations, which of course IFC is very good at of structuring. And then we bring that out as well. So that's the XY coordinates, spaces, zones. I'll hand over to Isan.
Thank you, Sam. From my side, I'd like to talk about the update on the mapping IFC to other ontologies, especially the mapping with the building device naming standards. As some mentioned, smart buildings should be designed to support both static data and dynamic data. In this brief, our smart building architecture, our metadata model in the middle represent the structure of building, including not only spatial information, M&E equipment, but also point information, and works as an index for a smart building as a single source of truth. And to create the kind of metadata, for instance, the spatial and equipment data could come from BIM, while the point information could be taken from a kind of BMS. In other words, in our construction industry, data is usually created by each fragmented discipline separately. So that this means we need to integrate the multiple different data sources to make metadata models. But it is not easy because asset names and identification information often do not match between different sources. So to solve this issue and create the metadata models efficiently, we believe it's helpful to assign a common identifier based on naming device standards to each data source. There has been already a W3C working group called the Building Device and Asset Naming Standard Initiative, with the goal to create an unified naming standard for building devices and assets. We have collaborated with this working group to align the asset abbreviation with IFC entities. Additionally, they have also defined the naming syntax specifications. So we are implementing it in BIM. This table shows the mapping of IFC and the BDNS. Here are things we have done so far. We have conducted weekly meetings with this working group, and we established one-to-one mapping between BDNS and the IFC entity. Out of 247 classes, excluding enumerations, we mapped 172 classes that are relevant to smart building information. When multiple BDNS abbreviation correspond to a single IFC class, we have labeled the recommended BDNS abbreviation. And also, we have mapped enumerated types as appropriate. The outcome of the mapping has been published into the bSDD as a dictionary for building device naming syntax. A total of 888 devices have been registered. This BDNS abbreviation, it may not be object or entity itself. So they don't have a property set without relationship with IFC entity. So next, I'd like to explain how to implement the BDS information to BIM. First, as Sam mentioned, we are working on the development of the information modeling guide. This guide will include a naming convention using BDNS to ensure the consistency data management. And also, it will align the rules for system and point information as well. And additionally, we try to create the information requirement for smart buildings using IDS. And we are also considering the implementation using bSDD and IDS. As Mirbek already explained details, but I try to quickly touch upon so as I mentioned, the BDM's library has been successfully imported into bSDD, so you can quickly using a plugin like this, you can quickly populate values to BIM from bSDD using APIs. This shows the workflow or to populate the value of BDNS abbreviation to IC name based on the BDNS naming syntax specification. This is the IDS created as a test file. It defines the requirement that BDNS abbreviation corresponding to IC entity is properly entered into IC name using regular expression. So also using API, using plugins, you can quickly populate values based on IDS. So as you know, our IDS is also used to be to validate the accuracy of IC, ensuring the information assigned as intended. So this the view on the right shows the results of the such kind of checks based on the test IDS file for IPC name. So as you can see, for those using the BDNS abbreviation accurately, this shows pass. Exactly. That's all from my updates.
How are we doing for time? Is it? Okay. I'll just quickly. Yeah, got time. Okay, so next steps. Yeah. Yeah, good. Okay. So next steps of the project. So we're definitely going to be continuing this work that Isan has been doing with the bSDD and the IDS. We want to build that out with more of the ontologies, such as the brick schema, the digital building ontology, other systems that we use in the smart building industry. We need to build that out. That's one part of the project. And then further to that, we want to explore other ontologies. There's a bit more research to be done in that case, and we want to see what the outside of the UK and Asia are doing. We want to look into what Europe is doing as well for their standards, and we need to ensure that that's being picked up in the project. And then we want to also to develop that framework for using the static data for generation of the live data. Okay. So really, we really want to strengthen the bSDD. We want to use it as our semantic hub for all information. So we can start to standardize the way that we're delivering smart buildings, because nobody's done that before, and it just needs to be a push in the industry, because everyone just does their own thing, which is a shame. And then we want to continue with that. Of course, you get the IDS being built off that bSDD generation. So really, the two subsets of work that we've completed and is part of the white paper is the BDNS alignment and the UDMI MQTT payload production. So that will be part of the white paper release. The next steps is definitely continue this great development, produce and similar to the smart building guide for information managers. We want to do one the other way around. So an openBIM guide for master systems integrators, so people understand that they can use these models, and they can understand that they build live data models all the time. This is just the same sort of thing. They're getting them in JSON format. We use JSON as well, so that there is alignments there. And then an official release of the white paper, which will show all the findings and actions. And then continue the ontology mappings and bring in the haystack and brick into bSDD. Thank you, Shen. That's great.
Got a question in the back here. Good job, Mr. Suchi. Question and comment, actually.
So let me know when you've finished classifying everything, because I have the back end of that, which is developing essentially, we'll say like an AI-driven workflow that can essentially, with a very high degree of probability, using GraphRag as well as Elastic to vectorize the data, essentially propose what, say if you have 10,000 remote assets, right, IoT assets, it'll automatically classify like what categories they belong in or what they likely are, and it'll extract it from essentially like a point cloud, build a bounding box around an object to classify the geometry, and then essentially tie that to the data, right, the live sensor data. What I don't have in that, this is the first part, I don't know if it's a question or a statement, is what you're doing, which is to actually create like a CSI kind of format for all of that data, right? Because it's different every time. Basically, the client drives how I annotate what how those assets are classified, like what I call them essentially, right? The ID I give them. So that's the first part. So please let me know when you figure that out. The second part is BACnet and MQTT really concern me because it's not end-to-end encrypted. So have you come across anything that is?
So BACnet SC is just, sorry, BACnet SC has just been released, and it's the Secure Connect protocol for BACnet, which is really watch this space, basically.
Because it scares the crap out of me, like especially on government projects, right? They usually they have an entirely secure subnet for stuff like this because they want the data and they're willing to kind of do a certain amount of risk. But obviously the ideal situation is a completely end-to-end encrypted and obfuscated data format.
No, Secure Connect is
Okay.
being released now, and it's got all your certificate authentication on it.
Oh,
and,
it does? Okay.
Yeah, so you can do that digital handshake, and it's cybersecurity is one of my my big passions. So yeah,
Okay.
it's definitely, it is changing now. So
Okay, great.
Any other questions? Comments, statements? No? All right.
So we have some technical issue with online participants of Peter.
Or we can remove the slide.
Yeah, we can move the slides. Yeah. 1 minute break. 1 minute break. Please stay here. Regarding bSDD for BACnet, there was an attempt that I tried with bSDD to cover that part. So actually, that's what you already mentioned, dynamic and static data. So actually, IFC is static. So if you need specific classes and specific attributes and specific properties that you need for your static dynamic information that will be used in BACnet, then you can create a dictionary for that. I tried the demo dictionary. It's available, by the way, in bSDD. Can try that and check one. Maybe you can give me a feedback what could be improved there. That the biggest problem was you in that case you're not not allowed. You shouldn't use predefined or p-enums, because if as soon as you use p-enums and you apply it to your IFC model, it will remain there. So it will remain static. So you can only use as a mask, maybe apply property, but without values, because values will go to different platform.
One more small question.
Sure, yeah, we have now.
Actually, a lot of your examples are, I assume, streaming based, right? We also have a lot of, say, more batch-like information or older information, but dynamic, but older information, not real time. I saw in one of your sheets also the CSV logo. So it's a lot of CSV files actually, right? Big ones. But it was in the static rectangle, not in the dynamic. But would you be able to do something with the CSV, big CSV files in the dynamic area there?
So
or do we also only have to go via the protocols you mentioned? Just the simple situation of having CSV data, dynamic CSV data available.
it's still static information though, isn't it?
Well, it's old dynamic information. It's non-streaming. It's just streaming versus batch. And we have a lot of batch stuff. That it's not all, especially in the infra sector, we have not typically streaming data, but batch data. But it is dynamic
you can get
data.
batches out, yeah. So that's more of an API like connection.
Okay, let's remember the issue.
So I see Peter and Sim and they're all online. Now we can start with the next presentation.
Okay, good afternoon. My name is Peter Lawrence, and I'm going to be giving you a project update on our fire safety engineering information delivery specification. It's actually two IDSs we'll be delivering, one related to fire modeling and another related to fire assessment. I will be giving the first part of this presentation. My co-manager for the fire risk assessment, Yun, will be taking over to look at the use cases, and then Sim will finish off the talk and give the background information. We also have another team member or team leader, and that's Peter Thompson. He coordinates the teams between the two IDSs we're developing. So what I'm going to cover today is give you an outline of our initial project scope, because we're looking at the very broad areas of occupant movement analysis and fire safety engineering, and they're two related areas. So I'm going to talk about our prior IDS, because a part of fire safety engineering is looking at occupant movement and evacuation analysis. And then I'm going to come on to this IDS that we were involved in at the time, give some background information about scope, timeline and teams. And then Yun's going to take over the use cases, and then Asim's going to deal with the tools utilised and related work and potential impact. So what was the initial project scope? So initially, we were going to look at all the performance-based fire engineering in one single activity. However, we found that to be too much to take on and would have produced too many different information delivery specifications. Now, the first presentation talked about prescriptive-based codes and performance-based codes for fire engineering. So prescriptive codes are looking at rules and regulations. And then if you're developing a design that's a bit more intricate or different to normals, you might turn to performance-based designs where you do a deep dive. And in that case, you would look at the occupant movement in the building. So you would analyze how people would move and ascertain a required safe evacuation type. So how quickly can the people get out of the building? And this is how our previous IDS and occupant movement analysis is related, because you're looking at evacuation analysis, one aspect of fire safety. And then you would also looking, this is what we're coming on today, the fire modelling. So you look at saying, can I select an appropriate scenario and look at a fire case, and you do a fire simulation, or you might do some other kind of fire calculations to establish how long people can survive in the building. When is the building becoming untenable? And that gives you a available safe egress time. So you really want your available safe egress time to be a larger time, longer than your required safe evacuation time. So that's the crux of the performance basis. So can people get out of the building safely in the event of a fire? And also, to complement that, we've got the fire risk assessment. So this is looking at assessing loss probabilities, different scenarios. So looking at the bigger picture in all and evaluating the risks involved in the design. So as I mentioned, I'll tick the occupant movement analysis because that project is now finished and now completed. And this just highlights that these are the two aspects we're looking at this project. So now, just to recap, because it's related to fire engineering, the IDS for occupant movement analysis project was completed. That was another 2-year project that was prior to this one. And the technical report for that was submitted to BSI back in November 2024. It was reviewed by the various committees, and it has been recently approved at the beginning of this month. And we've received from that process, we received some feedback. And this was useful feedback, which we provided from the committee members. The occupant movement analysis team is reviewing and using that information, and we're seeing how we can take forward with that. And we'll also be using it by this project team to see how we can improve processes and methods applied during the fire safety engineering IDS development. So, as I mentioned, there's two IDSs and there's two streams. So we got two streams looking at the processes and the data and the models and the testing. So for fire modeling and risk analysis, we're going to look at the processes, which we currently do, and we're working on the use cases. We've developed the use cases, and we're working at the processes involved in that. We also then, from the processes, analyze the data and do the modeling and the test. So we've got these two streams. So we're managing this as two streams. So we've got the overall project team, and with each stream, we've got a sub-project teams who will deal with those each individual areas. So how are the two areas related? So let's look at the data chunks of the jigsaw puzzle. So core to the two IDSs we're developing is the fire data, and this covers the source, size, and growth and smoke aspects of the system, as well as the materials and space and volumes. And then to the left of that, we've got the fire dynamics, which cover the fire, smoke, and transport. So we're looking at, from that data, the fire data, we're doing the fire dynamics, and then looking at smoke barriers, smoke extraction, sprinkler coverage, and structure. And then also on the other side of the equation, we've got the risk analysis. Again, uses the fire data, the work scenarios, probabilities, fire origins, costs, and itemized hazards and occupant risks. And then from those, we develop our 2 IDSs to extract those data for those 2 applications, for fire modeling and risk assessment. So that's the basis of what we're doing. And this is the project timeline. So it's a 2-year project. It's in 3 phases. We're currently well into phase 1, and it's now September. And we've already come up with our use cases, and now we're starting to develop our process maps. Hopefully in November, we have some process maps for our expert panels to review and look at, and we're currently working on that. And then from that, we'll be reviewing support for identified data requirements in the IFC file. So from those use cases and process maps, we identify what data is required from the IFC schema to produce our IDS, and then eventually we'll do the testing and validation and documentation. So this is an overview of the project team. So this is the core project team, and this comes from multiple continents across the globe, which is good for fire safety because we need to cater for all the different fire standards and safety protocols in different countries. And they don't just vary between countries, they can vary within regions and countries. So there's local fire safety standards. And along with this core team that works on those fire modeling and smoke analysis and risk assessment, we also have 2 auxiliary members. So we have Mirbek from buildingSMART Germany, and we have Emma Hooper from buildingSMART UK and Ireland, and they're there to coordinate what we're doing for the fire IDS between the other building rooms, because the connection with regulatory and other areas in the building domain. And also Emma is involved in the British standards for digital information management of digital information for fire safety. Furthermore, we've got our expert panel, and again, they're spread across Europe and the States, and they review the processes as we go along to make sure just to review and validate and check the process as it goes along. So at this point, I'm going to hand over to my co-project lead over in Canada, Yun, who will talk about the use cases as part of this project.
Thanks, Peter. Can you guys hear me? So I'll talk about use cases. The project team has identified several use cases. First, for fire modeling, the use cases will be developed to show workflows and processing when we do design checking of a high-rise building, make changes of building layout, uses or capacity, and potential remediation for a building, and even forensic analysis of an incident. Second, for fire risk assessment, the use cases will be developed to show workflows and processing when we do simple fire risk assessment in early design stage, like a schematic design stage, where we expect very low level of details. Another use case will show, again, the workflows processing when we do detailed fire risk assessment. This is particularly true in developed design stage where high level of details are available. In this stage of fire risk assessment with a detailed LOD, often the risk assessment is going to be scenario-based and require hazard data, and hazard data are usually coming from the modeling. So that's the fire protection system, like here shown, the detection system, suppression system, and smoke control systems. Those could be evaluated and sized. Next. So we're looking at the use case number 1. Usually in the early design stage, design information will be limited only to show pretty much conceptual design. The low-level details, such as building dimensions, principal floor plan information, construction type, method, and preliminary material systems to be used in consideration, and occupant profile. With this low LOD, fire protection engineers built fire safety design requirement, performance criteria and fire safety design procedure, including checking relevant fire safety standards and codes and etc. Also, fire protection engineer prepare conceptual fire strategy report in the early design stage. The fire risk assessment in this stage would be conducted with a very low LOD. So we often use simple qualitative methods like a checklist format or index-based methods. So these methods could be utilized to identify high-risk component or the system and in the building, and to evaluate the potential level of fire risk of whole building. So I'll move on to the next. The use case number 2 in performance-based design. Fire protection system designs are started with selecting design fire scenarios, including event tree analysis, as we can see in the slide here. So design and evaluation of our protection system in the developed design stage, of course with a high level of detail, often require quantified performance criteria. And in this stage, we use engineering tools, methods, analysis tools, including fire risk assessment tool. These complex tools conduct quantitative scenario-based fire risk assessment using detailed data extracted from the BIM model. So the data exchange must align with, of course, architectural design, occupant, the movement design, mechanical, electrical, plumbing design. With this high LOD, critical safety elements are assessed in depth, including the details, attributes as tabulated here, the structure, roof, facade, interior finishing material, and the list goes on. So I'll show you here. This slide shows the link between the fire risk assessment shown in the box in the middle, the yellow box, and the fire modeling, the pink box below, in the overall design process. This figure shows how fire risk assessment and fire safety engineering are integrated into the whole building project process, from planning, schematic design, development design, and construction design, and so on. As discussed earlier, fire risk assessment in particular starts as early as in the building design stage, ideally from the planning, so that the fire safety design brief could be prepared. And I believe that this is also required in BS 8644. And later, when we get to the detailed design, develop the design stage with the high LOD, the fire modeling and egress modeling could be conducted, of course, in the performance-based design framework. And the risk assessment in this stage will be conducted to support the evaluation of different mitigation solution options. But to be able to do it, we need two sets of data. One is likelihood of design fire scenario selected, and the other key data is consequence hazard data from the selected design fire scenario. So these are oftentimes in engineering analysis, we generate that by running fire modeling simulation, egress modeling, and etc. Finally, fire risk assessment shows then expected losses in terms of life or the property, the dollars. Or in some cases, if needed, we can also analyze the potential business impact disruption, so that the best performing mitigation solution and the fire protection system design could be selected and finalized. So I'll hand over to Asim so we can hear more about the fire modeling use cases.
Thanks, Yoon. So as Yoon mentioned, there are a number of use cases related to fire modeling, but I'm just going to include a couple of examples here. The first one is about high-rise building. And so we could use a hotel model, residential office building. Of course, there are differences in terms of usage, but there are a number of similarities as well. We are currently working on a process map for this use case and trying to identify data requirements. So we are in the process at the moment. It is also possible that we look at this use case very closely with the high level of detail risk assessment use case, which you mentioned, because obviously there is quite a bit of overlap. Another example, which is quite different from other use cases, is the forensic analysis of an incident. Obviously, this is not at the design phase, and there are a number of examples we could use. For example, the Station nightclub Rhode Island fire in the US in 2003. 100 people died and 230 people were injured. So multiple research studies have been conducted as far as this fire incident is concerned. For example, National Institute of Standards and Technology, NIST, Fire Safety Engineering Group at the University of Greenwich, University of Canterbury, New Zealand. So there's a number of studies have been conducted, and what we're going to do is, based on the information available, we will create a process map and we'll also identify data requirement. So these are the couple of use cases related to fire modeling, which I've mentioned, but there are others we're looking at. As far as tools are concerned that we have used so far, we use Microsoft Excel to identify all the relevant use cases and have a discussion with our team members. We're using Box to share project files, using Microsoft Teams to for our project meetings, and using Miro for creating process map, creating a list of initial data requirements and so on. But of course, we'll use a range of tools in phase 2 and phase 3 when we start creating IDS file and testing those IDS files suitable models. Next step, the project started in May this year, and we're currently in September. Our plan is to finish work on these use cases and come up with process maps, initial data requirements by the end of November. And then we'll have an expert panel meeting. Hopefully the feedback we'll get from the expert panels will address any issues. And then we'll move to phase 2 in January. As far as related work potential impact is concerned, this work builds on our work on occupant movement analysis. There was a Revit add-in developed, which is related to occupant movement analysis. Continue work on this. We'll try to align this project with other BSI projects. For example, the work done which Emma and others are doing at UK and Ireland chapter, also align with Mirbek's work and Manuel's. We'll also coordinating with Emma as far as BS 86441, which is digital management of fire safety information is concerned. She's part of the team reviewing that standard. Peter Thompson is also involved in writing a technical report for ISO as far as BIM and fire safety engineering concerned. We'll continue that work as well. NRC are working on performance-based design related aspects with in Canada. They will continue that work, and they are contributing to openBIM workflows as well. And NRC and University of Greenwich are also working in are part of a working group for digitalization and cybersecurity at SFPE US. So there is quite a bit of opportunity in terms of aligning this with various other works, and as you can see, there is a good chance of future impact of this work. And finally, I'll take this opportunity to thank Our supporters, for example, OFR Consultant and University of Greenwich, who's funding a PhD student who's also involved in this this project. NRC supporting Yoon and others in her team. Fire Emergency, Brands, Fire Research Group, GHD and University of Canterbury supporting Pete Thompson, and of course bildingSMART for their continuous support. And finally, our other team members and everyone else who's providing us with support. Thank you.
Should have switched our camera.
Any questions?
No questions?
No
We're right at
questions.
time, I know it's a little late. so.
Yeah. Any questions online? Yeah, you can read it out, or you.
What device types must be modeled for IoT? All the devices, all the connected devices?
It's only, connected IP devices. So anything that's on the network that's publishing data to the network, that would be fundamentally what we would want to have on there.